This is the last video for RTS 22. We're going to be covering 6 sections in it. So that's going to be music and sound, because I'd be remiss if I didn't include some of the artist work that they got inside of this. Some of the dynamics, it's just incredible, and I love how much it improves the experience overall. We're going to talk about AI pathfinding, because I promised that we were going to go beyond what the Unity NavMesh AI worked with, and what are some of the steps and systems for going beyond that. We're also going to go into camera controls of RTS 22, where I would, at least as far as I'd worked ahead, and the system for it, which include things like rotation, panning, and also zooming in, and then the MiniMap also supporting rotation and panning, and then also not zooming in but having transparencies on it, so it doesn't even have a border, but you can still see the rest of the map, and it works nicely. And then the menu, and I'm talking about main menu, I'm talking about the UX inside of it for giving commands and how I organize. There's a very specific structure in how I organize that to handle lots of commands, dynamically choosing when they should show up or not. And then the last part I want to talk about is minerals, which is going to have a very pleasing visual element to it. One of the key things that I've really liked about the visuals in this. And I wanted to demonstrate how I got that to work. And I can't find the shortcut or the code where I was starting to modify and simplify it down. But I'm probably not going to use this effect in the final version, so I'll just show in RTS 23. So this is I'll show how it was working for this one. Anyway, if you guys have differences of opinions, if you have other ideas for how we can approach this, by all means, please share that out in the comments. I'd love to see your way of dealing with these things. All right, so let's move on to the audio. So in this, I'm just going to play this, and I'll let the audio build up for a second in the background, and then I'll start demonstrating some of the changes. So this is the environmental system that's running inside of here. There was a very specific effect that I was looking for, and that's kind of sci-fi industrial horror. I wanted it to be an ominous effect, a sound that almost made you a little concerned or worried to move on to other areas. So as the lights raise in other areas, there's also an effect that ties into it. So I'm going to trigger one right now. You heard the effect that came in from that? That didn't make the music change. This is part of the natural ambient music that's in here. I'm going to move over to this one and make another intro effect to the lighting starting. So it adds on, and it fits so well within the dynamic music. Now, dynamic doesn't just mean that we have these effects going into place. This also means that there is a beat, a rhythm that can change if, let's say, we were suddenly faced with, wrong one. If we were suddenly faced with something more impactful. So I also did say that we had camera controls working in this one. Oh, I have gizmos on. Let's turn those off. You can see all the light effects and everything sitting around. I'm going to grab these ones, which this is a handful of them stuck together. And I'm going to change the music. So it very nicely tied over from one musical effect to another. So this is indicative of what a battle would be like. Suddenly battles starting, attacks are starting, and I want to be aware of that. Even if I'm not there, it's like, wait a second, what's going on? There's a fight starting, I need to go get there. So there's sound effects that can happen, but I really like the idea of the music changing to support that. All right, now let me turn it back down. So it very smoothly switched from one to the other, and all I need to do is just hit this one Boolean checkbox, and it just switches to the next one. Anywhere. All right, so let's take a look at how that works. I'm going to turn this one off. Let's go back to play focused and turn that So I'm going to get rid of this for a second, move it over here. And now let's take a look at the sound effects that are happening. So on the main camera, we have our listener that's in here, audio listener. And then I also have another starting effect. This is not final work. I primarily this was the last piece I put in here to make sure I got it included in this video, because I would be absolutely remiss if I did not include Cole Harmon's work in here, because he did some great audio. That audio mixed with the visuals really brought everything together a lot better. So yeah, I can't miss out on that. Anyway, so I just threw a couple things together, and again, this is not final. I'm not using any kind of audio mixer in here or anything, and I probably should be. But as is, I'm just putting in a mellow music source and an intense music source at the same location as the camera. So that makes it pretty easy to control. Now on this, there is a script here called Intense Music Swap. So over here, that only happens to exist on, on this particular object. So on start, it's automatically taking this music and telling it to set the audio observable for ambient music. Now this, just to let you know, this is a separate system. I added an observable, just like we've been adding observables for vector 3s or transforms. I added one for audio clip, or specifically audio source. So anywhere can just grab onto this ambient music mellow and adjust the volume level, adjust the pitch, adjust timing, whatever else it wanted to mess with, it could do. That was not something that was lost in here. Now, there are two sources in here. Oh yeah, and I should also include that on start, we're also setting intense over here to also get that information. So there's an ambient music intense value. Oh, not that one. This one up here. So in the data audio, I have ambient music, or music ambience and music intense. So anything in the system could just drag drop that into a separate controller and be able to manipulate the audios of the game. All right, now one other thing that this has is you see this intense music swap. Now this is a very lightweight script. Inside of here, all we have is the what are the two sources, so we just reference them. This doesn't have to be here, this could be on a manager. But for now, I decided to put it here. So we have a Boolean. Should we use the intense music? So it's just an on-off option that happens here. And then how much of a transition should we have and how long should that transition take? So right now it's half a second and it's done with the transition. Over here, this is the nature of how it transitions. So it starts faster and then finishes off a little slower for the transition from one effect to another. I could make that a much more bumpy transition. I could do other things to alter it just to get kind of an effect that I want. And here's the code. So inside of here, here's the fields that we were just looking at, plus the counter, which is basically just the private float that I'm tracking time with. During the awake, I'm adding a listener to use intense music. So that just calls this method down here anytime that Boolean value changes. So if it changes, we get use intense. And swap to intense. And right now I have a bug in here. It just turns it on, turns it off. Wait a minute, why is that even working right now? Because I'm switching enabled to true or false. I'm not actually turning it on and off with this. I'm literally just enabling it. Oh, that's right. Because this is affecting which controller is working, because I'm still taking a look at the effect of it down here, whether or not we use the intense music or not. This one, when we swap off from one sound effect to another, is really just telling us, hey, reset the counter to 0 and enable this. So we will go back through our update sequence, and during that update, we can start updating the times or the volume levels. So we start increasing the counter by delta time, and if we are done, if we've already passed the duration, the counter equals the duration, it is enabled equals false. Now, why is it set to counter equals duration? That is because this next one, I am saying lerp equals counter divided by duration, and I don't want to end up with a value like 1.1. If I'm at the end of the lerp value, I want it to be 1. It starts at 0, goes to 1. Okay, so I get the lerp value, basically taking whatever time. So if it's half a second and I am 0.1 seconds into it, that means that I am 0.2 or 20% into the lerp. For volume, we're using the transition evaluate lerp. We're taking that lerp and passing it into the animation curve, this guy. All right. So now we're just going to check to see if we're using intense volume or not. So if we're using the intense volume, then I'm going to say the volume just goes to negative. Not negative, but we reverse it. So if it was 1, it's going to go to 0. If it was 0, it's going to go to 1. If it's 0.4, it's going to go to 0.6. So we reverse that. And then I say the intense volume source equals our whatever volume we're passing in through this, whatever we've lerped, whatever we've evaluated from the lerp. So we set that to the intense volume. And that's why if it's not the intense volume, then we reverse this. And then the mellow source is the exact opposite. So basically we're doing this reversal of it twice here, depending on if the if statement is called. Okay, that's all it is to transition from one to the other. I could have something more intelligent in here. I could have a longer slope period. I could have more duration. I could have it set up so it never actually closes off the other one. I could have different slopes for each one. Now, how I'm going to deal with music in the next one, we'll see. I would like to pull in dynamics again for this. Whether or not I'm the one creating the music, which I haven't created the music for these in a while, or if I end up, if Cole Harmon decides to agree to work with this again, that would be awesome. If not, he's already done an immense amount of work with this, and I want to showcase his website. So 2 things on here. Let's see. Here is his website, so you can actually get here and find out more information, check out his resume, projects he's worked on, which I was witnessing some of these other games that he's done, and they're pretty awesome. And then over here, this is the actual pack. You can get this over at itch.io on his profile page, where you can get the same audio that you heard on here with instructions on how to work with it and examples. And of course, you just saw how I'm working with it in this set, and got to see some of its effects and how it works in this specific project. The next part that I want to cover is that more intelligent AI navigation. So as I right click over here, you can see the units are gathering around this point, but then they are reprocessing themselves into immediate files that they can sort to very quickly. So that enables us to have all of our units get set into position so that they can quickly start firing right away. So let's get into the code. How do we make this work over what the normal AI system works? So let's jump into code. So there are 2 effective commands. There's the move command, which is one class, and that's basically the button or the monitor of the right click to detect when we did a right click, to then issue the move to commands to all of the individual units. The separate one is move command handler, which is what the individual units have in order to maintain the command that they're supposed to execute. Okay, so let's start out with the move command. So we have over here vector3 observable, and we have the last right click point. I want to call one quick thing out with this. This is code from RTS Course A. This was test code building up what I was doing with the project RTS Course D that I have been publicly releasing on YouTube so far. There may be some variable or class name differences between these, but since this was effectively the test base to start putting those into the rest of the stuff, it should mostly be the same or close enough that it'll make enough sense. All right, so over here we're just on the start function, we're saying, hey, add a listener for the right click point for the move command. I'm also on destroy, making sure I'm removing this because units can get destroyed and re-added, and I want to make sure I'm cleaning those actions up. I don't want to be making a bunch of null action calls to this. All right. So anyway, if the right click point changes, it's going to call this move to function. Now, honestly, this can be responsive. I think that was part of my testing, and I couldn't figure out what I was actually doing with it, but it doesn't do anything right now. I don't think anything uses this. All right, so we're going to skip that one. Everything always works. Okay, so the next thing we're going to do is we're going to check the spot that we click, that right click point. is that something where a NavMesh sits? Is that somewhere over the NavMesh? So we're sampling the NavMesh just to see if it exists. If it doesn't, if we're doing a false check, we're just going to return. We're not going to move to. If we right-clicked on the background somewhere where it's just over empty space and not over the map, we're not sending there. That's default behavior that I've seen in most RTSs. Okay, so next we have, we're getting the movers. The movers are the move command handler. Remember, this one is the main command, and it's going to pass that instruction off to each of the individual move command handlers. Okay, now on the selection manager, I did add a function on here, a really basic function. It just basically goes through every selection in there and calls a get component for whatever type we're passing in here, and yield returns it. So in this, I'm creating a new list of all of those selected items that have a move command handler. And so now I have this list of move command handlers, the movers. I get the count of it because I'll be reusing it, and I get the first one that was in that list. There is no real intelligence to what that means right now. So there are reasons that we might change this in the future, but right now it's effectively just one of the items at random it selects. Okay, so now we're going to get the landing points. The landing points is pretty basic. I just, inside of this, I have this function called get sequence of positions, and all it's doing is it's making a square. It starts from the center, goes up by 1, then goes, once it reaches that, it'll go out by 2, then it goes down by 2, then it goes over by 3, then it goes up by 3, then it goes over by 4 and down by 4, etc., incrementing every other time. For how many steps it goes per side. And so it's basically just creating this diamond or square pattern that we will effectively see our structure shape in. We can put different intelligence in here, have different shapes. It tries to shift out positions and define it based on what is the most effective, including for that type of position. Right now, the code is based on just a list of positions with no intelligence in mind. So those are all upgrades we can account for later. All right, so over here we have NavMesh sample position. We're basically just checking to see if the position is there, and we return it right away. Okay, so we are yield returning that target that we were going to. We already know this one is going to work because we effectively already had it on there. That first position always returns 1, so technically we didn't even need to call a sample position on this. We could just return it right away and subtract from the locations needed, and that's fine. Because this is private, and we know from our previous function that we were detecting that that first point that it starts from was accurate. Okay, so from there, we're going through, as long as we have more locations that are needed, this integer we've been passing in, so if we had 10 items selected, we've got one of them right away. It was that point that we actually right-clicked. Now it's going to start building these positions going out and around it, and starts incrementing that as it goes, and does another sample position check for these targets in the new position that it's going to. And finally, once it actually gets here, if we get to here and it samples the position, it's going to change. It'll check the locations needed or reduce them. And then finally we start our counts, which increments and starts changing our position. It changes where we need to go, which effectively happens after it loops again. Okay, but if the locations needed are done, we could break out of this at this point. However, we don't need to, since it's in a while statement. As soon as it gets to the end, which this is all very light processing work, it's not like iterating through lists or anything like that right now. It's like one line per, or one processor step per on command on this. Okay, so once that's done, we've got all of our positions. That was the square. Remember, it's just creating a square. We can add more intelligence to this later. Okay, so now we're creating a new travel group. The travel group is really lightweight. The travel group has an initial target that it will go into that. But remember, all of the units were going to one initial target first, and then once they got there, or at least within range of it, they would select one of the positions based on which was the farthest away, or starting with the one that was the farthest away. So let's go over here to initial target, scroll back down, and there we go. Nope, not that one. Where did I leave off? We got update, we're checking the distance, we're checking, okay. Yeah, so we've got our distance. Well, let me just move backwards so I can detect and make sure I'm right where I needed to be. Oh yeah, so we got to create our travel group because every unit, even if it's only going to be one unit, is going to become a member of a travel group, even if it's just a one-member travel group. So everything processes in groups in here. Okay, so we set our landing points. We want to basically find the closest point to begin. So we go through every one of these and figure out which one is the closest by checking the distance and comparing it to our previous shortest distance. At the end, we will have group.initialTarget, which is set. Now it resets the target by the first one that you go through, so you've already got something there. Okay, next, now that we've got that in there and we've got our initial target set, we are going to call the move to command on every single one of these. So let's head into this one. So the move to command that's on this, it effectively says, here's the group. Now we're going to set the destination awaits, which is really just, it's setting a value to what this might equal, and destination awaits is an object. That way I can put a vector 3 in it, but still make it null. And then we're going to start a coroutine to set the destination, because destinations in Unity NavMesh AI can take multiple frames, and that's good. Because if you have a really massive terrain or a really massive area that the NavMesh has to process against, it can take more than one frame. Or it can take a long time, and you don't want to freeze your game up while the AI is trying to process. It's better that it processes it in chunks. Okay, anyway, so once that's done, the destination will be set, but the update command is effectively running inside of this. This is the command handler for that specific unit. So we're going to check, first off, do we have, we're going to say how much remaining distance do we have to our destination. And that's just being reported for debugging so that I could test this. I technically don't need that information there anymore. Next, I have the group. If the group is null, there's no move command. A unit has to be part of a group to be moving here. Otherwise, it ignores it. And we can simplify this processing by disabling this game object unless a move to command has been set, and then disabling it once it completes the move command. So the update wouldn't run all the time. Right now, I'm taking a shortcut to make it easier. This was the test code. Okay, so we're also checking to see if the group is null. We're checking to see if the destination awaits is not null, because we're still waiting a destination at that point, so we're not going to run it. Okay, so at this point, we're in a group and we're not awaiting a destination. So we're going to find our distance. How far are we from our destination? And if our distance is less than the distance prior to next, which is part of that group setting, which right now just defaults to 1 meter, if we're farther than a meter away, we're going to just return. We're not going to do this yet. But if we're less, we'll continue. So now we're going to go through every one of the points, and instead of getting the closest one, we're going to get the farthest one away, because all of the units are coming in from one spot, and now we have this group of spots, so it's going to select the farthest from that location. So as each unit is starting to come in, it will start to navigate its way out to those individual points, and they won't be competing to get there because they're already sorted right as it happens. There can be some complications. We've seen a little bit of twisting as multiple units get within range within the same frame, for instance. Or they're kind of grouped alongside each other as they're coming in, and so they have to swap sides. That can also cause some complications in here. Okay, so anyway, after we have this destination, the destination, we remove it from the group positions. So it's no longer a position in the group, but we reset the destination target so our unit will just head off on its own, even though it's no longer part of a group now. And then finally, we set the group to null. That's it. There's also the on-draw gizmo selected, and that's just saying, hey, set our color to some random color, which it figures out at start, just random HSL color. And then we draw a line from our current position to our destination, and that's just for debugging. All right, I only briefly want to talk about camera controls, just so you kind of get the idea of how I'm doing this, but I'm going to approach this. Every single system is very different, so I don't usually share as much about this part. I'll plan on covering more of it in RTS 23. But, so here's some of the things it covers. As I click and drag with the left mouse button, then it drags along and follows. If I zoom in with the scroll button or zoom out, that's the maximum out, this is the maximum in, it zooms in and zooms out. And then when I drag again, it still follows the mouse pretty well to keep and maintain the speed of where I'm dragging from. Okay, next I have, so rotate as well. So I'm also rotating. So anyway, I get the rotation in there. I get to see what we're operating around, where we're working. This camera system is pretty straightforward. Let me show you the code for it. I actually have it sitting inside of managers. Oh, I should point out there is a camera root, and then there is the main camera. So you can go a mathematical route, a very strong mathematical route where you're applying this long line of mathematic structures in order to make your code or your camera physically move the way you want it to. And if you're far more comfortable, for me, I'm more comfortable with code logic than I am with math. So I don't like the approaches that are so strong in the mathematics side. That being said, when it's necessary, it's necessary. But a lot of times it's not. Cameras, honestly, it just makes so much more sense to have a separated out parent unit that when the parent unit moves, so if this is my camera, when the parent unit moves, it's like I'm moving an entire stick, and I can understand, oh, if I have that parent unit right on the object that I want to focus and I take my camera and tell it to look at it, then if I rotate, then I'm actually rotating my camera around that spot and getting different perspectives, and I don't have to write a huge amount of code to make sure my angles are right, that I'm translating to the sides, that I'm taking care of my corners and all of the various differences in speed, things that are going to change over time. I don't want to manage all that. Anyway, so I've got the parent object called camera root, and I have main camera. So over in managers, we have our camera manager, which we have access to the camera, and we have access to the camera root, which we're calling camera track inside of here. So if we move the camera track, that still moves the camera, but maintains its zoom level. So when I'm panning, I'm actually panning with the camera root. But then I'm zooming in and out by moving the camera away from the camera root or closer. Then we've got rotation speeds. Rotation speed is a constant. But then we have zoom in and zoom out. There's a subtle rotational difference that happens on the zoom in and zoom out. So when I'm zoomed all the way out, it's like I'm looking at this from the top down for the most part. When I'm zoomed in, it takes a little bit more of a side perspective. So actually, if I rotate around, I can see this wall here when I'm zoomed in. But when I'm on this side, I cannot. Now, if I zoom out, I can see a little bit of a difference, but it's really not much. It's like 15 degrees versus the other one 50 to 80 degrees, where I'm looking for 90 degrees here. Okay. Let's see. Was there anything else I want to cover in this? Oh, some basic things. When I'm zooming in, I establish that I have a zoom in level. I take my camera track, the root, and I set that up that is my base level. That's where I want my camera. If it's zoomed all the way in, that's where it is. And then I will add to that when I'm zooming out and basically just zoom out on the Y level, moving away from that position. So I use the camera track as this anchor, or the root as an anchor, and then I have the camera itself backing out and away. And then I have less to control because for the camera itself, it only has to look forward, or it has to move up and down and potentially zoom a little bit this way. Zoom a little bit on its x-axis so that it starts to spin and look up or down, depending on where we are. Like we're high up, so we're starting to look down. And when we're zoomed in, we're going to be looking over. And that's the difference of 50 degrees versus 80 degrees. Okay, zoom in and zoom out. So the Y height, when we're zoomed in, we are 15 meters up from the actual ground in here, 15 meters up. And when we're zoomed out, we are 60 meters up. So I could raise this up to like say 250 and then zoom out some more. But now I've just got another mini-map, and the rest of my speeds don't really make as much sense. There are ways to make a lot more of this work out in our favor. But right now the zoom speed set to 60. Let's go back to that. There. That's better. Okay, and then also how we're rotating around stuff, and that's how fast we're actually spinning here, if there's any change in difference, which honestly there's not much change in speed when we're actually zoomed in to zoomed out as to whether or not we're moving stuff. But when we're dragging, so when we're zoomed in, there's ways that you can do this mathematically where you're identifying when you click and drag, what is your distance from the camera. So when you have a ratio that works, that when you're dragging it feels like that right amount of drag speed, you can be using how the distance from the camera changes as well as it starts getting away to start indicating how you can change its movement. I'm not doing anything that complicated in this. I'm just using two things. So I've got the lerp based on the zoom. Am I 15 meters away? Am I 60 meters away? This 15 meters away is a lerp of 0 and tells me to use the zoom in speeds, and being zoomed out to 60 is a lerp of 1 and tells me to use the zoom out speeds or zoom out rotations, whatever piece of information I want. And so I have one that at 60 meters out, when I drag, this tells me roughly how fast I should be dragging this to make sense out of the world for the speed to match up. But when I zoom in, this needs to be a lot different because I drag all the way across the camera or all the way across the scene, and I only move about one tile from one side to the other. If I'm zoomed out and I say, well, let's look at this tile and move it all the way over, okay, that moves that one tile over, but there's like 6 other tiles that disappeared during that movement. Okay, so this stuff is fairly straightforward and I don't want to spend much time covering it. I'll just go into one tiny part about the code. So inside of this is a general structure where I've got those same fields you were seeing in there. During the start function, I'm gathering information like its position and angle to begin with. And then during the update, I am calling the handle mouse drag, zoom, and rotation. So it takes care of each one of those individually. And I find that by separating out those pieces into separate components, you can focus on the different elements of math you need. So in this case, we're rotating around. We're setting how far forward should we be rotating around. We've got all sorts of different things happening inside of this, but it's fairly straightforward. Handle mouse zoom, we're getting the lerp, which is the mouse scroll delta. We're finding out how much we've actually changed. And then we're applying a math rotation. How far are we rotating? So this is the rotation on the x-axis. And then how far are we zooming up and down, moving up and down across the y-axis? And that is right here. We're lerping between the different heights that we're going to be using. Okay, and then finally the last one is drag. We're just taking the zoom in drag speed and zoom out drag speed based on our zoom lerp. That it's not perfect, but it works remarkably well, so we don't have to actually make it perfect. All right, let's get into MiniMap now. So the MiniMap, as you can see in this corner over here, we do see a MiniMap, and as I rotate, this rotates with it. If I'm dragging, we don't see drag, and same thing with zoom, it doesn't zoom in on it. But it is transparent, so you can see through it. I decided on this element over having a border and having it an actual picture that completely blocks off a section. In this case, even though I won't be able to see everything, I can still see a lot of stuff that's happening under here. So if enemy units are starting to show up in this corner, I can still tend to see that information. Okay, so how does this work? Is this transparent map that I can see what's going on in the rest of the stuff? So basically what I'm doing is I'm taking a separate camera and I'm taking a look from the top down. So if I go over to MiniMap camera, I have this over here, and it's an orthographic camera, not a perspective, so I see it straight down. And I lose perspective angles on this. which for an overview map, that works better. It also makes the math apply better, so when I have this image, I can potentially put other things on it and be able to get them to line up just fine. All right, so there's that thing. Now the camera is also doing something else. First off, it's not set to main camera, it's just untagged. And then also down for, not environment, but for output. For the output, I have an output texture. So there's a thing called a render texture in Unity where basically you can have a camera or some other process just automatically applying to it. And what this tells Unity is that we need to keep updating, when we're using this type of texture for a material, we need to keep pushing new copies of that material in, or of that texture in to memory for the video card to use. So it keeps reprocessing it and running it again and again and again. Okay. Whereas most of the textures you just load once and it's good. You're never going to load it again. Okay, so we've got that in there. We're taking this MiniMap texture. Here's the MiniMap texture. To get a new one, we can just right-click on Materials or whatever folder, and we can come down to here and we can say Custom Render Texture. Now, when you do that, you're effectively getting this thing, where it's going to be 2D in this case. The size is usually something small. In this case, 256 by 256. That is the maximum extent that I'm putting in for a map. Anti-aliasing, you can have that in there if you want. The color format, if you don't want alpha in there, you don't have to include the alpha channel. You can set this up to use 256 colors. You can set it up to use 2 billion colors. Anyway, so, and then also the stencil format, you've got other pieces of information that can be in there, MIP maps, etc., which I can't remember the nature of when you need the MIP maps, but we don't need it here. All right, so we've got this item being built out. It's a 256 by 256 bit texture, or pixel texture. All right, so that is the capture. That's where it's going to. That gets pushed into a material. The material has a reference to this and starts pushing it out. So every time there is an update on this, it updates the material. It updates what that material looks like. So I'm seeing it get passed through here, and the material actually updates this. All right, no code is required for this. I do happen to have one piece of code. If you go into MiniMap, I should have on MiniMap, which is not in here, I have something to deal with rotation. Oh, rotation is happening on the managers. So we have the camera manager, and I'm also controlling the MiniMap rotation on this. So the MiniMap rotation, we're basically just seeing what angle are we actually seeing this from. Okay, so this system that controls the camera really only needs that same rotation information and to just pass it on to the MiniMap, and that works pretty well. All right, I want to talk about the menu now because the menu has something very special hiding behind it. I should have expressed it at the beginning, but it's hiding the tech tree. The tech tree code is already written inside of this, how I'm going to manage the tech tree inside of an RTS. I have been dependent on this for a while, and it works great. So I'm going to keep using it. I'm very open to hearing other alternatives for this, but this has been managing the tech tree and making sure that it remains flexible for all sorts of different levels to be able to make alterations to, has been one of those things where it always feels challenging, feels kind of difficult. So I wanted to make something where we can manage this very easily. So let's talk about this. We've got different menu items here, and these are commands that we can effectively run. We have the move command, like we select a unit and we can move it. And then we have create drones, drone level 1. Now, these buttons, here's something kind of interesting. Let me play, and we'll just kind of go through some of the initial motions to begin with. There's no UI. No UI is there. So when I right-click, nothing moves anywhere. If I select something, now I get the move command. So I could use the move command. I can also click this. I don't think I have that wired up to actually trigger to indicate a left click after I do this. So it's still dependent on right click at the moment. But anyway, we get the move command there. Now the move command, if I take a look at this over here, Actually, let me just disable this now. So we saw that the move command enabled. Something about that button became visible. So let's also take a look at this. What if I take that move command and from here, while the game's not running, I disable it? The drone takes its place. That's because everything inside of here is showing up inside of a scroll view, and inside of the scroll view we have a grid layout. The grid layout is automatically taking any disabled elements and basically ignoring them and only aligning the elements that are visible. So as soon as an element becomes disabled, it automatically aligns everything else inside of it. That works great. It also sets the cell size for everything. So we just say, here's the size of this, here's how it's going to show up. This is the amount of spacing we have in our grid that's available, which in this case, I'm just using a stripe across the bottom. And the way that I have my command structure written is that when you select multiple units, you effectively get every command available to every one of those units to show up. So if I select a move command, I can click on a structure and 20 different types of units, and it will show me the move command. And when I click it, those 20 different types of units will move. The structure, of course, will not. Okay, so how do we disable it? What makes us decide to disable it? Well, if we take a look in it, there's a very simple thing in here. So I've covered observables already in this, but so basically we have a Boolean observable. So if I take a look at this code, we're looking for a Boolean observable, which basically means it's a true or false piece of data. It's either true or false. It's named, and so in this case, we're calling it show move. Should we show the move command? So we're deciding, should we show the move command, true or false? That's pretty straightforward. On startup, we add a listener to check to see if that Boolean value changes. And then we also call the exact same function anyway right away to set the value of this immediately, whatever it's set to coming into here. Okay, and so we say on Boolean change, and we pass in a true or false value. And so on here, all it's doing is it's triggering an event on true or on false. If it's false, if it's false, it's going to trigger whatever else. So in this case, it should be fairly obvious what it's going to do. For the true, if we should show the move, it takes the entire game object, this move button, and sets it active to true. And when it's false, it sets the activity to false. So it doesn't show it. It disables the object. That's all it's doing. It's hiding and disabling the object based on these Boolean observables. Now, this does require a little bit more complexity in this. Booleans, this is also using a Boolean AND gate in this case. So if I go over to this Boolean value and I click on it, this show move, you can see it's not just a simple value of true or false. It's actually made up of multiple values. And if you're not familiar with a logical AND gate, it's basically the same as an if condition. If this and this, it's only going to be true. It's only going to run the code block if both conditions are true. If all the conditions coming across it are true that have an and separating it. All right, so that's the same thing happening here. Both of these values have to be true. So these are two other Boolean observables. If I were to take a look at drone selected, this is another just simple Boolean value. That's all it is. Something's going to change it. So something dealing with the selection is going to decide, do I have any drones selected? And if I do, I'm going to set this value to true. And when my selection changes, if I don't have any drones selected, I'm going to set this value to false. Okay. So in addition to that, show move also has we have drone selected, but we also have move unlocked. This unlocked list right here, these Boolean values are our tech tree. Do we have move unlocked? Yes, we have move unlocked. So all of our stuff is unlocked right now. We technically don't have the ability to build a drone because I don't have any buildings or structures inside of this yet. But that's it, this structure. So then we can have logical gates like, can we research something? Can we research something such as how to build a tank? let's research how to build a tank. So you research it and you have this little script that's going on, doing your own timer or whatever. And then when it's done, it sets a value in here for move, not for move, but for tank unlocked. Tank unlocked equals true. It sets that to true, and suddenly you now have the ability to create tanks. That's really straightforward and clean. Another system that goes on top of this is that I will likely be there will be some levels of complexity that will be likely changing in here. For instance, when a level starts, if we're not going with the defaults of what's available, then I'll have something else that comes in and says, okay, well, we're going to change these particular values. So to begin with, we're going with a level 3 value, which is going to just automatically write out whichever ones of these unlocked things there are. So when we start a level, it's basically just going to say that all things are locked and then unlock them based on what the level permits. Additionally, we can throw another one in here. It's incredibly easy to add one that says drone unavailable. So it doesn't matter if the technology becomes unlocked, if you've got the research for it or whatever. If it's unavailable, like maybe there's something happening in the level and you can't use flying machines. So that suddenly means, okay, it doesn't matter if I have this technology unlocked. I've got another AND gate, another AND condition in there that says it also has to be available. And everything by default would be available, and everything by default would be locked. So the menu, the level at the beginning of the level would effectively come in and say which one of these is this going to change. If it needs something special in the script, it's going to choose which ones to change. Okay, so another feature on this is that once we actually get to this, we can say level 3. If we have a standard state for the map, we basically would just say at the beginning, we would drag in the different items that are going to go into what Booleans are going to become true, what Booleans are going to become false. And that's it. It's a really straightforward setting. Anyway, so that's how the menu works. Really easy, really straightforward for having the visuals show up here. It ties directly into the tech tree, which makes the tech tree management pretty straightforward. If you want to find any item, it's not really like a masterful list where you see an item and then see which ones it unlocks. Instead, you see each individual section that's in here and say, what unlocks this? And if you're in a game and you're testing it, you can just go over to that button and say, oh, well, what's supposed to unlock this? Because I can't see that button. And so you go find the UI and it's like, oh, well, the UI is not there. Put it in. Oh, the UI is there, but it's still not showing up under the conditions I'm expecting. What conditions is it looking at? All right, and then I take a look at those Boolean values. What's setting those Boolean values? Where are they coming from? And you can track down and find this stuff really quickly and easily. All right, so I briefly want to talk about an asteroid pack that I ended up pulling in for this. This is going to be to cover the mineral visual. Now, this has a really great visual, and I wanted to show you this. One of the things that I wanted to do was this part of the effect, I wanted a block, or this basically like mineral rock that would be charged up and then light would start glowing and exploding from the seams of these cracks that are kind of shaking and vibrating violently until eventually it explodes into these glowing rocks that have been charged up, and now it's ready to be used and harvested. So I wanted to find a pack where we had these rocks that could automatically separate. It was either that or pull in some code and try to attempt to refracture this stuff. I was taking a look at breaking it down. In this case, it's easy enough that this would have made sense not to be a script, but just to be models, which is what I ended up pulling in. Now, this asset, the breakable asteroid from Chatterbox, worked out really, really well. It's free, available on Unity, so another one of the free assets that I was able to pull in for this that just works great. So on this one, when I'm looking at the code for this, let's see. Oh, might as well just play it. There. So you can see that these are the different minerals that as they fall, they kind of shatter into these pieces, and that works nicely. And then these are all the shards of the different pieces. So we see this is what it looks like. The quality is pretty good from a low poly perspective. All right, so let's go into the game and see how I'm using it. Here's that rock that you're seeing. Now, I add multiple lights to this. I was not looking at how to make this performant. That became a goal afterwards that I have a separate project on, and I had some tests that were doing pretty well without using the expense of additional lights. Now, that being said, the lights are isolated. They only operate on the individual layer of this particular object. So one is inside and provides this bright shine from within. And another one is outside to add all these reflective changes from the outside. And then there's also particle effects that are going on. And let's just show this. So this takes 8 seconds for this current configuration to happen, but you can see we've got the sheen highlight, you've got all of these scripts happening. If I move my mouse over it, you see it highlights them. Anyway, that was it running. So let me go ahead and play again, and let's go to full screen. So let's pause. Oh, it doesn't stay up there when it's paused. Let's just bring that up there. So you can see it's the same one, but the pieces are being realigned. We have these lights that are moving around in here. We have these particles that are kind of flying off. It's just using the basic little default additive circular sphere particle. Nothing particularly fabulous. I mean, that probably would have done better to actually use something more geometric shaped, similar to the rock fragments themselves. But I'm getting this really strong glowing effect coming from here. So as I step forward, you can see that individual pieces of this start to move. Every single frame, we get other pieces that move. Upwards of, I believe, 8 pieces inside of this at any given frame will move. So, and until eventually the whole thing just explodes, which is a change in the physics where we suddenly turn physics on, and part of that explosion is the fact that rigid body suddenly became active. It was no longer kinematic, and pieces were overlapping, so that just pushed it apart. Now, some of this is happening within the game. Where is... Oh, there. Okay. And zoom in and zoom out is not working right now, but I did a hack to the camera to get at this perspective, so that makes sense. I'm actually kind of surprised that drag works here, but I guess that would. Okay. And rotation works. Okay, so anyway, I've got this object and it breaks it into all these minerals. Let's take a look at exactly how that does it. So inside of here, let's take a look. This is actually made up of all those different little fragments. I'm in game view. Let's go to scene view. And then from scene view, I'm going to turn gizmos off for a second. Whoops, not the element that I meant to do. Where was gizmos? There. Okay, so I've got these objects, and then I can select one of the pieces individually and move it, and you can see here it is. And, oh, wrong button. But you can see here it's got kind of the inside cutout, but then outside we have this external piece that's a little smoother and more rough that matches up with the edges. Rounded and rough, I should say. That matches up with the outside of the shell. But it, of course, goes right back in, and then it's hard to tell aside from the lighting that's it's breaking it apart. Okay, then this also has a separate thing. You can see that this mineral clump, it's got all these little child rocks underneath it. It also has a core light in the center of it, and it has 2 random exterior lights that can move around a little bit. And there's also an effects that's happening in here. So if I page down, let's see, where is the effects? Oh, it's actually a child element of the root object. It's a component of it. Anyway, but we've got this mineral pop script. So making the mineral pop. We have access to the core light that we can deactivate once it's on. We can turn up the intensity. So whatever intensity it is to begin with, we're going to bring that intensity up to 1,000. Now, this is operating on a layer. If you take a look at this, this is layer mineral. So it will affect other mineral pieces that are right nearby, but as in right now, it's only affecting 100 elements because this is broken into 100 elements, going up to 99 and starting at 0. Okay, we talk about the vibration max, which is how many meters it can move during a vibration state. And remember, it's starting light. So time to pop is actually building up. I could have done this on an animation curve so I could have this gradual change to how it shakes. But quite honestly, just doing it on a linear increase for how much it can shake worked great. So rotation max, they can also move up to 5 degrees per frame by the time it completes its duration, which is 8 seconds. Now, normally this might be less, it might be longer, it depends on what we're doing. The rock parts, you can see there's 100 rock parts in it. The particle system, we're controlling it there. We've got the ending material, because we're literally going to change out the material on the rocks. And then one other thing that's on it, well, let's get into the code. So this code, here's all those fields. Everything was public except for the rock part original rotations and positions that are null or private, and then also the counter, which is just used for time tracking. Okay, during the startup, we're getting all of the original position and rotation, so we know where they are. Why do we do that? The reason that we do that is so that during a frame, when we tell something to rotate a random amount or move a random amount, it's not a random amount from where it is from the previous frame. It is a random amount from where it started from. So basically, we're allowing it to have a total maximum difference of 5 degrees and a total maximum difference of 0.2 meters for any individual component within that. From the base component. And all of the components in there can be individually different. Okay, we also tell the particle system to stop, and so this is on the start. And then we also disable this script. So the particle system stops, the script gets disabled, so the minerals are there, they're present, but we're not really able to interact with them. Now, there is a thing in here called execute at start, and that's just for test. It's a Boolean value in here, and if I set it to true, that's what makes it operate, so it'll just sit inside of the game. So if the execute function was run, then we enable this game object, which means our updates will run. We tell the particle system to begin playing, and we also call the invoke for onBegin. If we take a look at here, we have onBegin in case we have stuff that's going to be running for this. We also have other things during onComplete, another one of the events that it can execute. Okay. All right, so at this point, we are currently running the frame. The object is enabled. We're running the frame if we have already started this process. And so we're starting our counter. We've got our intensity going on here, so we're gradually increasing our intensity from 0 for the lighting all the way up to whatever our lerp is. Now, the lighting has 2 sets of lights that affect it. So we have the original lighting in the scene, but then we also have our light that's isolated to it that only shows up for the mineral layer. Okay, so on vibration, actually this might only be mineral layer, I don't remember, but once we press start, it drops down to 0 for the light. So the first frame will be 0. Then we set up the vibration. How much vibration? It's the lerp times the vibration max. Okay, great. Then we take our original position, our rock part stop position, get the original position, and we are adding a random inside unit sphere for times this vibration max. Same thing, we do this for the rotation. And so we've got rotation, and we've got, let's see, position. Oh, we're doing positions first, then we're doing rotations. So we're actually translating 4 different elements. 1, 2, 3, 4, 5, 4. Yeah, we're doing 4 elements at a time. So I could reduce this to 1, but it didn't have as much of an effect. This could also just be a loop, a dynamic loop. Then we can decide how many pieces it affects. But it certainly doesn't need to affect all of them. When you're doing a mass change like this, a lot of times just having a few of them change, it adds a richness to it to kind of make everything actually look nicer. All right, that's it. That's all that this does. Once it's done, once the update is finished, so over here you can see if the lerp is greater than 1, let's expand that out. We're going to go through every single part of the rock parts. We're going to find the rigid body, and we're going to deactivate its kinematic. So it won't be kinematic anymore, and that means that it's not driven only by code for how it moves. It is now going to be driven by the physics of the neighboring objects around it. Now, we unlock all of these rock parts at the same time, and a lot of them are partially overlapped, so the physics system has to push them apart, and we end up with this explosion that happens. It's usually not small. That percentage of overlap and move has a strong influence on it. So the higher we allow those to go, the more of an explosion it can have at the end. It also provides more visuals, but we could put an extra layer of control in here, saying at the end, the last frame when it does this, the material, all the objects can be moved, but it'll only be at 0.3 degrees or something, that the rotation can happen, and 0.1 meter or something. So we can control the effect of this at the end. We're not doing that here. Anyway, so we set the material to equal the new ending material, which is that glowing material. All it really is just a blank material that has a strong bloom. It has no lighting value whatsoever except for bloom. So we're using post-processing. If we turn post-processing off on this as a way to shut down features on this, make it more performant on a lighter machine, then we would lose this ability. It would be black effectively. Actually, I'm pretty sure the color is also white, so it would still show up. It just wouldn't have that glow effect. It wouldn't darken the area around it when it pops. And then, of course, we set the parent equals null because we're getting rid of the root game object. So over here, we go through each one of these elements, but then we disable the extra lights. We stop the particles, we disable this game script, we call the onComplete to trigger any other types of things that it needs to close out. We destroy the root game object, but that's fine because all the individual fragments are now part of the root game. Though that should have a parent somewhere else. And then we leave. That's it. This object is now done. It is gone from the system. That being said, gone from the system, of course, means over here. Let's go ahead and hit play, and I'll just let this run. So there you can see it's just running, blah, 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 blah. It'll eventually pop. There, it popped. Now we have all of these elements just sitting here in the root of the system. If we take a look at the material that they're running, let's go over to Mesh Renderer, and I'll check Rock 12 Emissive, but this is it. We do have a base surface color, so it will show up even if I don't have emission on. So if I turn emission off, they all pretty much are black. There's like no light on this layer. Oh yeah, there's no light on that layer. If I turn those lights off, they're gone. So this is literally just black at that point in time. Anyway, so I would have to consider that for systems with lower performance because the players wouldn't be able to see it and that wouldn't make any sense. Okay, but that's all our minerals. They're showing up. That's how it works. That's how we get our rich mineral system. Now, in the new version of this, which I couldn't find the code right before I did this, but I'm not going to be using this in the RTS 23 anyway, I had changed this over so that a shader was handling all of it. There was a randomization for where it was doing additive colors to the emissive edge. And then it was also determining all of the faces that were pointed towards the normal or within less than a 90-degree angle or less than a 95-degree angle of normal. And if that was the case, because of the way that this was fragmented and was pulling chunks off the outside, every single chunk is pretty much guaranteed to have about a 90 degree or just slightly more than a 90 degree, but it has to go out to like 130 or 140 degrees before it hits that surface. So it just checks from the center point, which gets passed in as a vector 3. From that center point, where is the edge that I'm looking at, and then get the normal from that. And if I get the angle and the angle is beyond or for that surface is beyond a thing, then it colors it. It adds an intense color. So I was able to do the lighting effect without needing more lighting. Then suddenly I could drop the lights. Awesome. Similarly, the same shader would then just control the final process for it. So it would have just an if condition to switch off which state it was using for this. And it was pretty straightforward and easy. I will likely want to pull in some effect like this for the final, for the RTS 23. So I'll have to consider what seems appropriate for it and end up diving into there. But this is everything for the system. I really hope that you found this to be particularly valuable in here. this is the last thing for RTS 22. If you have any questions or comments, any ideas about this, some of the stuff I'm going to be pulling over for how I approach things, but some I won't be. Some I'll be doing differently because the nature of the game is a little bit different, and so the structure of the architecture that I'll choose, the patterns that I use to lead to the UX are going to change. But some of the pieces will remain the same. So I'd love to hear your input. What do you think is working well? What do you think doesn't work well? What are some alternatives that you've used? And that might provide me with some insight as well to potentially choose a different path. And I will plan on calling anyone out that does give me an idea that I'm planning on going with. Unless, of course, a whole bunch of you contribute at once. Yeah, whatever. If a bunch of you contribute at once by the time that I get there, then great. That'd be awesome. Okay. Talk to you later.